Okay, so the last talk is by Eric Reagan from Texas A&M University, and the title of the talk is Balancing Privacy and Information Disclosure in Interactive Record Linkage and Visual Masking. And this paper has received an honorable mention, so please join me in congratulating the co-authors.
Thank you so much, Carrie, for the introduction, and thank you, Roberto, for helping up with the presentation setup here today. So I'm going to be producing work today that's similar to looking at the balance between privacy and utility of data, similar to Roberto's talk, only with a very different context in terms of data. Our group is related to addressing problems with tackling real data systems and how to approach these practical problems that people have when you look at applying data science to real problems and real applications across a variety of different domains. And because we're looking at problems across a variety of different domains, the work that I'm presenting today is from a variety of different teams that we pulled together in a true interdisciplinary effort. So we have the main thrust of this work is from Dr. Hajang Kum, who's also here today, in our population informatics lab. And then also with our HCI and visualization research, with our support and interest from Patient-Centered Outcomes Research Institute, who's interested in all kinds of factors of watching out for patients, medical patients, and their interests and concerns. And the work that I'm talking about here is motivated by this problem that almost all of the data systems that we have in the world, there's so many of them that have people-centered data. There's data about people, information about individuals. And whether this is medical data or financial data, sensitive information about a particular person, or a collection of information about from individual people that has helped to make different types of decisions about economic factors or financial interest, fraud detection. There's a lot of cases where you need to look at the individuals as well as the whole. And so, of course, the problem with this is usually when we're looking at people and the data associated with people, obviously privacy is a big concern. We usually say, well, we want to maximize privacy, so don't give people access to that data. We don't want to show people the details. But of course, that's a big problem, because if you don't give people access to the details, then how can you do real research with data? How can you benefit social science and make decisions that benefit mankind and research communities? So we do have some partial solutions that are commonly used. Things related to just say restrict access. Don't give anyone access, but then, okay, well then you're also restricting progress. There's also, of course, algorithms and automation. As we talk about in HCI, like we'd like to talk about human in the loop. Well, this approach is just take the human out of the loop. Just automate things and rely on the algorithms to solve the problems for us. And then, of course, there's other information where you can use by looking at the whole of a population, just looking at aggregate of different types of data with people-level data, and being able to identify inferences on larger populations together. But there are problems with all of these approaches, where none of these are really ideal if you want to maximize data integrity and quality data when you're trying to do decision-making and a lot of types of use of information that involve making sure that your data is what you think it is. So some examples here, if you want to do whatever types of legitimate data analysis you want to do. Again, if you're trying to do fraud detection, or if you're trying to, you need to be able to look at specific outcomes from anomaly detection and identify why are those anomalies. Or if you're trying to do information related to healthcare and you want to be able to pull out different types of inferences that require knowing some specific details to help you understand what is really going on for individuals, you need to be able to know that data is accurate. So there's a lot of cases where you have to do data cleaning and make sure that each record that you have of personal information is accurate and reliable. This is also a big problem of merging data sets. When you're pulling information from multiple sources, you want to make sure that it's the same. So we have this big issue of this trade-off between privacy and utility if we're trying to support these human-centered decision-making processes. Usually the way this works is we have some algorithms that can automatically figure out some of these issues for us, but then ultimately a person needs to review and make the final decisions because the algorithms are not quite perfect. So our research is addressing this problem of how do we balance this privacy of disclosure of personal information. We don't want to let people see everything necessarily, but we want people to see enough so that we're not sacrificing utility and actual outcomes of our data science and our data use. And so that's the topic of this talk. We're looking at methods of limiting disclosure without negatively affecting human performance. And to do this, I'm going to be talking about a very simple method of just hiding data values, but also adding metadata to be able to help in decision making. And the context for this research is based on record linkage with person-level data. So record linkage is this idea where you have information about people coming from different data sources. And you need to make the decision of, are these actually matched people? Can we take the information about this person from multiple places and use it together? Does it give us more information about the same entity? In this case, the entity is a person. Now, this is a trivial problem if you have some kind of primary key, some kind of unique identifier that you know and you can trust. But a lot of times you don't have this. If people go to different hospitals and you're trying to connect them and have different medical data from different places, or you're trying to connect their medical data with other kind of financial information from completely different sources, you're not necessarily going to have a unique key. Or people might not provide the key. You have missing data all the time. So we have real problems where you don't know whether or not two records really are referring to the same individual. So a lot of times you get cases that look like this. So here we see Charles Green and Charles Green. We have the same name. We have the same day and month of birth, but we have them at a slightly different year. We have to make these decisions of, do we think this is the same or different? And we have a missing ID number, which maybe that's a registration number or a social security number. And now we have to make this judgment call. A lot of times we're able to look at algorithmic approaches to automate rules that can figure out when to make these best decisions. But again, these algorithms are never going to be absolutely perfect. And if you really care about the quality, people trust people to review the outcomes and be able to make a final decision. And it gets really, really hard because there's lots of different types of contexts and real-world situations that could introduce discrepancies and challenges in making these decisions. Typographical errors is an obvious one. People mistype in data all the time. If you're trusting a receptionist to type in your data, you have these problems as well. People go by different names. Nicknames are very common. Certain names also have different variations of spelling, and that can be easily mixed up if someone else is entering that data. And then there's also other types of even more complicated issues, like family-related issues. A lot of times people change their names, such as after marriage, or people having the same names if they're in the same family. Twins, for example, is extremely problematic because we have a lot of twins are going to have the same birthday for some reason. But they'll also have the same family name, but other different names. So how do we distinguish whether or not these are truly separate people or if it's the same person that had some information changed? So in order to study this trade-off in our technique, we designed an application that presents these different types of results of the algorithms to do this record linkage and matching of different pairs of potential people that might be the same people from different systems. And to make it easier to identify what's going on here, we use visual markup, some extra visual annotations to identify the types of discrepancies between records. So we see these different types of icons that show up that can let you know were additional characters added, or is there a major difference, was there transposition between data values, or they're missing data values. Additionally, we can make it even easier by adding some type of metadata. So what we did here is add different icons related to the frequency of names in the data set. So if you're wondering why do we care about frequency of names, well, if two people have the same name, it becomes important to know that how common are these names in the population in order to make your decision. If people have very, very common names, you wouldn't be surprised that you have several people that have the same name with those very common names. So our application generally looks like this, where each pair of two rows together show two different records related to people, and how you see these different icons that show up in each field being able to highlight different types of differences. But what about privacy? We can see all the information that we need to see about this person to help us make these decisions, and our icons give us extra information, but we still are showing all the information related to these individuals, which we don't want to do. So the other aspect of our method is to do some simple data masking. If we use some type of simple toggling and saying if the information is the same, can we hide those values? So here's what it looks like. If this is our original data value, and we know that some of these fields are the same, maybe we just replace some of these values with some check marks or some extra characters. So what we see here is, for example, this is a date of birth. Same date of birth. We simply replace this with a check mark. If we're looking at merging these data sources, a reviewer or a decision maker doesn't need to know the specific. They just need to know if they're the same or different. In other cases, here we see that there's a last name and different name, which are the same last name and different name, but in different fields. We have switched last name and first name, so maybe that could be important to make your decision, but you don't need to know exactly what those values are in some cases. Are there other cases where you do need to know the specifics? And so in some cases, we might want to addressing here is, when can we just do this data masking? When is it enough to just completely hide the data, and when is it important to show that information? When do you need to see the details? And to solve this question and learn more about the limitations of and these trade-offs between balancing privacy and utility of decision making, we did a controlled study. So to do this, we did, of course, had people do a record linkage task related to this application, where we used data that was perturbed from publicly available voter registration data that we modified to suit our research question, but in a way that we had ground truth for that data set, so that we know with consultation with experts if these two records and our sets of pairs of people would refer to the same person or different people. So we did this as a lab-based study that was done between subjects where every participant did one of 5 conditions. The distinction between all these different conditions for exactly what they saw can be broken down to basically 2 main ways. One is if you're going to show them absolutely everything, but the difference is they either have this visual markup or they don't. The other important difference is how much data hiding, data masking do you impose? Where at the top level here, you're showing all the different types of data and you're showing just the visual markup. And at the bottom, you're masking all data values. You're not showing any individual characters at all. You're just showing these different types of symbols. So to look at it a different way, we could also looking at just consider it as an amount of characters that are disclosed. So again, in our baseline condition, we don't have any type of visual annotation, and we're revealing all characters. In our full condition, we are showing the visual characters, the visual markup in addition to all the characters. And then we also have these other variations where there's a drastic reduction in the amount of characters that we're showing. So we did this experiment with 104 participants spread across these 5 conditions. And of course, we had to give people some tutorials, instructions about how record linkage works and different things and real-world problems to keep an eye out for before doing a number of trials. And in every trial, they would be looking at these pairs and ultimately scoring on this choice panel where they have to decide whether or not this pair is the same person or different people. So we'll jump right to the results and take a look at what we had here. And what we're showing here is accuracy results. This goes from 0 to 100. Keep in mind that ultimately what we're doing is correctness based on correct or incorrect, and there's a binary decision here. So really, we'd think about around the 50% mark would be guessing. But the important thing to note is that we see there was no significant effects of the visual markup, which makes sense because people did pretty well when you have full information. So there wasn't really any room for improvement. On the other hand, if you look at the implications of doing the data hiding, you can see that there was a significant effect. Notably in these last 2 conditions where we had a little bit of a drop of 6% when we're doing a pretty aggressive amount of data hiding, and a pretty large 10% drop when you're just masking all data values completely. So when we look at it a different way, we can want to bring up here the individual percentages that we had for these conditions. And what we can see here is really, really interesting is we notice that when we have this moderate level of masking, where you're only showing 30% of all the data characters, we still have pretty similar level of performance than when we're showing the full characters. So this is extremely promising, a very nice success that we have with our simple data masking technique. We can also look at this other result of when we're doing complete data masking. So this is 0% of the data showing, and yes, this is a reduction I mentioned of 10%, But on the other hand, this is still 75% accuracy, which is pretty nice. That's not too bad considering that this is completely legally de-identified data. We're not showing any characters from that personal information data set. So in terms of reducing privacy risk, this is a really, really nice technique for real applications just because of its simplicity. And it leaves a lot of extra questions in terms of if we want to be able to hide data values and be able to allow people to make real-world decisions without sacrificing the quality of doing that, but also without providing extra information about people, it gives us some opportunities. It's pretty exciting that we have comparable performance with around 30% disclosure of that information, but we think we could also do better. And we're interested in exploring other ways of even reducing that 30% character disclosure down even further and still having high performance. So we're exploring that in our continued research. And we also want to look at other ways that maybe we can have 0% disclosure, completely legally de-identified data, and increase our decision accuracy up from that 75% error. And we think we could do that by providing more metadata to help people make more targeted decisions, by providing more information to help them make the decisions that they need, the types of information about the discrepancies that they really want to know. So at this point, I'd like to close things up here. And again, thank PCORI, the Patient-Centered Outcomes Research Institute, for their support in this project. And I'd also like to invite questions from, I'm here, and also ask for Haishang Kum, who is the real lead of this greater research project. We would love to talk to you more about this work. Thank you.